taker. This note taker will be on the metric system, and there will be a few notes at the end to talk about measurement. Now, with the metric system here in the U.S., we're a little bit behind everybody else. A lot of the other countries have already gone to the metric system while we're still using standard units. Now, the problem with that. When we try to do conversions between the different units, we know that there are 12 inches in a foot, there are 3 feet in a yard. So then when we go to try to figure out, well, how many inches or how many feet are in a mile, there's all this complicated math and we need a calculator to figure that out. When we talk about the metric system, however, the metric system is based on the unit 10. So anytime we go 1 unit bigger or 1 unit smaller, we're either multiplying by 10 or dividing by 10, which is as simple as moving the decimal point left or right. Another difference with the metric system is there are only 3 units of measure. We have the grams, the liters, and the meters. Unlike our standard units that we use here in the U.S., we have, even just for distance, we have inch, foot, yard, we have miles. When we talk about size of an area, we have acres. When we talk about measurements in recipes, we have teaspoons, we have tablespoons, ounces, and we don't just have liquid ounces, we also have dry ounces. Then we have pints, gallons, quarts. To make matters worse, we also have all these weird ones like fathom and furlong, which also refer to distance. But with the metric system, we're going to have grams, liters, or meters, depending on what type of measurement we're taking. So let's look at liters. Liter is a measurement of volume. Volume is how much liquid takes up a space. So here in the picture I have on the left, I have a 2-liter bottle of soda. Those are the large sodas that you see at the grocery store. And on the right, I have a 500 milliliter bottle of water. That's a regular size water bottle. Actually, that water bottle is a half a liter. So if you have 2 water bottles, then you have 1 liter of liquid. When we talk about a gram, it's a measurement of mass. Mass is how much stuff makes you up. Very different from weight. Here's an example. If you took your weight here on Earth and then went to the moon, you would weigh a lot less because there's less gravity pulling on you. But mass, being the stuff that makes you up, your mass here on Earth would be the same as your mass on the moon. 1 gram is equivalent to about 1 large paper clip. Not a lot of stuff. So if we look at about a 150-pound person, we're looking at about 68 kilograms. Kilogram is 1,000 grams. So when you're trying to determine weight versus mass, kind of a little bit better. The numbers look a little bit better when you're taking the mass because they'll be a little bit lower. A meter is a measurement of distance, and 1 meter is just over 3 feet long. When we're measuring distance, we're seeing how far from point A to point B. So in the top picture, battlefield with an arrow pointing to, that's a drawing of the front of the mall. If we were going to measure from here to the mall, we don't want to use a meter that's only just over 3 feet long. We're going to use something called a kilometer, and it's roughly about 5 kilometers away, which would be about 5,000 meter sticks away. Textbooks, because they're a little bit smaller, if I was going to measure the width across a textbook, I'd probably use something smaller than the meter. I'd probably use centimeters. There are 100 centimeters in 1 meter. You can go ahead and fill in your chart in your notes with these prefixes and their abbreviations. Now, the one I need to show you is that the deca, which is right between the hecto and the base unit, we will be using the abbreviation DK, not the DA. So when we look, the middle box, which says base unit, That is 1 gram or 1 liter or 1 meter. If we put kilo, hecto, or deca on the front of any of those words, like kilogram, hectogram, or decagram, we're making that unit bigger. If we use the prefixes deci, centi, or milli, and again, those are prefixes, so they have to go on the front of gram, liter, and meter, so we can have a deciliter, centiliter, or milliliter. These are going to make the unit smaller. So if we look at a gram, a decagram is equivalent to 10 paper clips, 10 grams. A hectogram would be equivalent to 100 paper clips of material, and a kilogram would be equivalent to 1,000 paper clips of material. Now, if we go to the right with the smaller prefixes, if I took a paper clip and broke it into 10 equal pieces, one of those pieces would equal a decigram. If I took that paper clip and broke it into 100 equal pieces, one of those little pieces would be a centigram. And if I took that paper clip and broke it into 1,000 equal pieces, one really little tiny piece there, that would be a milligram. Now, with these prefixes, you are going to need to know them in order from largest to smallest, because we're going to be, in a couple of slides, we're going to be converting between the prefixes, and you have to know what order to fill your chart in. So at the bottom of your first page of notes, you will see a word that says mnemonic. It actually starts with an M, not an N, but the word is mnemonic. A mnemonic device is something, it's a way, a sentence, a phrase that helps you remember something in order. When you were in kindergarten, you probably learned Roy G. Biv. That's red, orange, yellow, green, blue, indigo, violet. That's the order of the colors of the rainbow. And they are in order from red all the way to violet. When you were in 6th grade, they might have taught you My Very Excited Mother Just Served Us Nachos. That's the order of the planets from the sun out to Neptune. When I was your age, she served us 9 pizzas because Pluto was still a planet. For these prefixes and the base units, grams, liters, meters, I've given you a sentence here. So go ahead and write that down in your notes, and I would memorize this. It's a lot easier to remember a sentence, even if it's a silly sentence, than it is to remember the prefixes. So the sentence is, kangaroos hop down glaciers, ladders, mountains, drinking chocolate milk. If you can remember this sentence, then you'll be able to fill in your charts when we get to the math portion. Now, how to convert between the prefixes. This is called the ladder method. And if you know how to count to 6, because that's the most you'll ever have to count to on this chart, and you know the difference between your left and your right, then you'll be able to do the ladder method. The hardest part is finding your starting point and your ending point. So let's look here at this problem. 4 kilometers, and I want to know how many meters are in 4 kilometers. First of all, we need to determine our starting point. That is the K for kilometer. So we're going to start all the way at the end of the chart at the K. The ending point is an M all by itself. If it's all by itself, it has to be the base unit meters. It cannot be milli, because milli is a prefix, and that M has to be in front of something. So now we're going to count hops. So we're going to start in the kilo box. We're going to hop to hecto, 1 hop, hop to deca, 2 hops, hop to the base unit, which would be your meter, 3 hops. And we hopped in the right direction. So what we're going to do is we're going to start at the decimal point, which would be right after the 4. If you're 12 years old, you don't normally tell people you're 12 decimal point years old. So when we have a whole number, we tend to drop that decimal. But when we do this math, you'll need to put that decimal behind that number. All right, now we're going to hop 3 hops to the right. 1 hop, and you will see how the decimal moved. 2 hops, a decimal moved. And 3 hops, here is where the decimal ends up. Now, we've got 3 empty loops. We need to fill these loops with zeros. So our answer would be 4,000, whoops, our answer would be 4,000 meters. Let's try a few of these together. The first thing we need to do is we need to fill in our chart. Remember the sentence. Kangaroos. Oops, let me get my pen back, guys. Right. Kangaroos, top, down, glaciers, ladders, mountains, drinking chocolate milk. Now, we do have one problem. I've got 2 D's there. One of those D's needs to have a K with it. Here is the clue. Keep K's close. If you do that, the D that's closest to the kilo should have that K. Okay, now let's look at your starting point and your ending point. We're starting with a centi, and we're ending with a kilo. Now we have to count hops and determine direction. So we're going to start with the C, hop once to the D, twice, 3, 4, 5. So it took us 5 hops in the left direction. I'm going to come here to the decimal point in the number. 1, 2, 3, 4, 5 hops. Here's my new decimal. I put zeros in my empty loop. So my answer is 0.000392. Let's try another one here. Let's go in the reverse direction. We need to fill in our chart. Kangaroos, hop, down, glaciers, ladders, mountains, drinking chocolate milk. I'm starting here with the DK, and I'm going to the D by itself. That's 1, 2 hops in the right direction. So I'm going to start at the decimal. 1, 2 hops to the right. Here's my new decimal. Put a 0 in the empty loop. And my answer is 650 deciliters. You will be doing more practice with these in class today. Let's talk briefly about measurement. Next class, you are going to be using the triple beam balance, the graduated cylinder, metric rulers, both meter sticks and regular rulers, and we're going to be using thermometers to take measurements. You're going to practice reading the numbers off of these tools and hopefully understand what these tools are each used for. We're going to start today with the triple beam balance. The triple beam balance, you see the picture here, and there are different parts, the set screw, pan, sliders, beams, and 0 point. The ones that we're going to concern ourselves with are all the ones at the top and the 0 point off to the right. You don't need to worry about the set screw in class because I will have already calibrated all the machines for you. While the pan is empty, you're going to move all 3 of the sliders. You're going to have a big, thick slider in the middle, a thinner one towards the back, and a tiny little thin metal one on the front. You need to move all of them to the left so that they're lined up on their zeros. Then you're going to put the object that you want to mass on the pan. The first slider you move needs to be the 100. You're going to move the 100 and make sure it drops into its little slot and determine, is it more than 100 or is it less than 100? If the part of the beam at the end, this part here, if that drops all the way to the bottom, then that means that 100 is too much. You need to move it back to the 0. If that part that I circled in green only moves down a little bit, then maybe you need to try moving the slider to the 200. And you'll keep doing that until you figure out how many of the hundreds you have. Then you move the back slider, which is your tens. You're going to use the same process that you went through for the hundreds. And when you're all done figuring out your tens, then you have the tiny little metal one in the front to use. I think it's easiest to use kind of the tip of your pencil to slide that along. It's a little bit easier than your fingers. And that's going to give you your ones and your decimal place. Now, it would be nice if you could estimate to 2 decimals, but on your worksheets and on your quiz on measurement, I'm only grading to the first decimal. So as long as you have that first decimal point right, then you'll have that answer correct. Once you have all the rockers in place, or sorry, sliders in place, you need to add the values. So let's assume that the 100th slider went to 200. Let's say the tens went to 40. And let's say the ones went to 7.3. When I add these all together, I drop down my 0.3. 0 plus 0 plus 7 is 7. 0 plus 4 is 4. And we drop the 2 down. So this, with the unit of the G at the end, would be the proper measurement for whichever object we had on there. Graduated cylinder is used to measure volume of a liquid. So the first thing you need to remember when measuring a graduated cylinder is that you need to be eye level. If you're looking from the top or you're looking for the bottom, you're going to get an angle and it's not going to be the correct answer. The other thing you need to remember is that when a liquid goes into a cylinder like this, sometimes you will have a curve, and that curve of the liquid is called the meniscus. You need to always read at the bottom of the meniscus. So you're going to read at the bottom line where it comes across. So if I was reading this cylinder in this picture, I would have 40, and then I have 41, 2, and 3. So I have 43, and since it's right on the line, my decimal point would be a 0. If it wasn't right on the line, I would have to estimate what that first decimal number would be. And since this is a graduated cylinder, we are measuring in liters, but we're going to use milliliters. That's the proper unit for measuring in a graduated cylinder. Okay. Looking at the ruler, you need to first of all make sure you're on the proper side of the ruler. This side is the bad side. That is your standard units. You need to look at the side of the ruler that either has a cm or sometimes you might see mm, which is a millimeter. The millimeter is referring to each of the little lines here. The centimeters are referring to the numbers. So let me draw on the picture. We'll say that the ruler is lined up to a piece of paper. Now, if I wanted to measure that, I have to look at the last whole number that it passes, which would be 1. Now I need my decimal place. For my decimal, I need to count how many little lines does it go over. 1, 2, 3, 4, 5, 6. We're going to stop at 6 because it doesn't quite get to the 7. So the answer for the length of that little tiny piece of paper would be 1.6 centimeters, cm. And again, it would be nice to get you to estimate to 2 decimals, but I will only be grading up until the first decimal to make sure that that one's correct. The last measurement we're going to look at is temperature. With the metric system, we are using the Celsius side of the thermometer. So when we're reading these in class, please make sure you're using the proper side of the thermometer. And like the ruler, you're measuring, you're looking at the last whole number that you passed, and then estimating to the first decimal. So if I were to look at the thermometer here on the left, again, I'm going to use the right side, which is C, and my value, I have negative 30. Now, look at the little dashes in between the 30 and the 40. Since there are only 5 slots, and there's 10, 40 minus 30 is 10, I have to take that 10 and divide by 5, and I get 2. So each of these little dashes is going to be worth 2. So that first dash underneath of negative 30 would be negative 32. And now I need to estimate a decimal. It's not right on the line. It looks like it's about halfway between, actually not even quite halfway, probably just under that line. So I might estimate that at a 3. And then we're using Celsius, so it would be degrees Celsius following your units there. With the estimated number, especially here on the thermometer where it's two units for each of those little dashes, do your best at the estimate. I'm looking that you're not too far off the number, but if you're, 1 or 2 off, like on the decimal point in either direction, I will still count that correct. So you will get more practice with this in class later this week. Today, once we're done taking the notes, we're going to work on doing metric conversions, and we're going to practice choosing the right metric unit for your work.